In this video, we will be talking about a chemical that made the list of the top 100 chemicals of greatest concern in the United States, generated by the Agency for Toxic Substances and Disease Registry. This specific chemical is the gamma isomer of hexachlorocyclohexane, or in simpler terms, Lindane. We'll be talking about its structure, uses, toxicity in the body, and its regulations in the United States. Now, it should be noted that Lindane's chemical formula is out of C6H6Cl6, just for you to keep in mind. Like I just said, Lindane is a gamma isomer of hexachlorocyclohexane. Now, hexachlorocyclohexane is a manufactured chemical produced for its use as an insecticide, and each of its isomers has a different toxicity effect. As you can see, Lindane is a chlorinated hydrocarbon chemical, meaning it is only made up of carbon, hydrogen, and chlorine. Because it has a chlorine in its structure, it is going to make the molecule to be highly resistant in the environment, especially to high temperatures, resulting in low biodegradation rates that allow for its high persistence in the environment, bioaccumulation, and toxicity. Regarding its chemical properties, Lindane comes in the form of a white gas that has a slight musty smell. It has a melting point of 112.5 degrees Celsius and a boiling point of 323.4 degrees Celsius. And an important characteristic is that it is fully insoluble in water, with its organic solvents being of ethanol, ether, and benzene. Now, Lindane's ability to quickly volatilize and leave no significant traces on the plants being sprayed made it ideal for it to be used as an insecticide. Now, you're probably wondering how this chemical works. Well, Lindane interrupts the insect's central system. Specifically, Lindane is absorbed by the insect's exoskeleton and blocks GABA, which is a neurotransmitter that stops certain nervous motions from happening. This is produced in the brain. By doing so, it leads to the insect's central nervous system to be hyperexcited and accelerated, which results in convulsions and eventually death. Because it only affects insects outside of their egg form, it must be applied a few times within the same site. Now, thanks to this, Lindane was applied in large quantities across agricultural fields. In fact, it is estimated that a total of 600,000 tons of Lindane was used globally in agricultural fields between the years of 1950 and 200. Okay, now that we've talked about all the good things about Lindane, let's talk about why it's made its way to the list of top 100 toxic chemicals in the United States. Interestingly, there have not been many toxicity tests performed on this chemical since the EPA declared in 2004 that chemicals used as a pesticide would not be reassessed or further tested by the Integrated Risk Information System. Nonetheless, the amount to which the population can be exposed to without significant effects is out of 0.003 milligrams per kilogram per day. Its NOAEL, meaning the highest dose at which no adverse effects are noticed, is that of 0.33 milligrams per kilograms per day, and its LD50 has resulted in being different for species tested, but that for rats is 88 to 190 milligrams per kilograms. Additionally, the OSHA set a limit of this chemical in the air within the workplace, which is 0.5 milligrams per cubic meter of air, during an 8-hour workday for a 40-hour work week. Lindane can be absorbed through the body orally or through inhalation, with toxicity effects being much lower when inhaled. Its short-term health effects are noticed after acute exposure through the inhalation that causes irritation of the respiratory tract, anemia, and itchy spots on the skin. However, the more concerning effects that make this chemical dangerous are those from chronic oral exposure, which cause severe liver and kidney damage to the central nervous system that results in convulsions, and finally, heart damage. Now, many have questioned if Lindane actually has some level of carcinogenicity associated with it. Interestingly, some animal studies performed by the OSHA have suggested the potential for Lindane to be carcinogenic. However, other studies have failed to prove this, and there is still not enough evidence to prove this chemical's carcinogenicity. So for the meantime, it's not considered to be. Now, if you made it with me this far, you may be wondering why Lindane causes so much damage to the kidneys and especially the liver. Well, Lindane itself is not as toxic, but once it enters the body orally, and the body begins to break it down, it metabolizes into chlorophenols that are highly toxic to the body. This mainly occurs in the liver. Now, these chlorophenols are moved through the body and eventually released through urine. However, chronic exposure of Lindane leads to unsuccessful excretion of all chlorophenol metabolites, and they begin to accumulate in the body tissue due to their hydrophobic properties. This accumulation leads to damage in the kidneys and liver, and at times results in the inhibition of the gamma receptors in the brain, just like with the insects, which can lead to convulsions. So what about Lindane now? Well, due to the discovery of all of this, the use of Lindane in agricultural fields was banned in 1983, but it was still produced and sold internationally. However, in 2009, the use and production of Lindane was then fully banned in Europe, cutting the amount of Lindane produced in the United States substantially. Before its agricultural ban, licensing was required for its use and application, and today the only strict form of Lindane regulation is in its disposal method, which must follow very strict rules due to its high persistence in the environment. Another form in which Lindane can be found today is in small quantities under prescribed shampoos and creams meant to treat lice and mites. Also, some people can be exposed to this through unwashed foods or seeds that were imported from countries that do use this insecticide still. As I've been mentioning several times throughout the video, Lindane's persistency in the environment is pretty alarming. Now, its persistency is due to the fact that it tends to attach strongly to organic matter in soil, and thanks to its chlorine components, biodegradation can only take place in oxygen-poor conditions, which takes a very long time. Additionally, its volatile and hydrophobic properties allow it to travel across the atmosphere quickly and disperse in areas very far away from its source, ultimately accumulating in mammals, fish, and even plants. For example, studies have discovered that walruses, seals, and whales in Alaska have been found to have traces of Lindane in their fat, even though Lindane was not used or manufactured in areas remotely close to them. So, with this in mind, what do you think? Should the use of Lindane still be allowed in other parts of the world? And if not, why?